How Florida's red tide makes the best catch of the day. Imagine going to a beach on a hot sunny day, but instead of crystal clear blue water, you see a reddish brown murk in the ocean. Doesn't sound too refreshing, huh? Well, that's what is known as a red tide, and today we'll be discussing what red tides are, what triggers them, and what we can do as a society to mitigate their harmful effects. As we dive deeper into the topic of red tides, I feel that we are faced with some pretty critical questions. First, how have long-term changes in global climate patterns and ocean current circulation influenced the distribution and dynamics of red tide in Florida over geological time? Second, how might current and future climate change impact red tide dynamics in the region of Florida? And finally, how does water pollution and human activities affect the occurrence of red tide blooms in Florida's coastal waters? Have a look at this striking aerial image of a Florida coastline from the year 2018. Do you notice anything a bit unusual? Well, that widespread red tint in the water you can see is a red tide blooming in full swing. I feel it's important to note that these blooms can stretch for miles and miles and miles and can actually be seen from space through the use of course, satellites, making for quite an eerie and unsettling sight. What are they and why they matter? Now that we have a pretty good visual understanding, I'd say, of what red tides look like, let's dive into the details of what they are and why they matter. Red tides are a natural phenomenon caused by rapid growth of microscopic algae called Carina brevis, and these algae are present usually in the Gulf of Mexico and can multiply quickly under just the right conditions. When the algae reaches extremely high concentrations, they can alter the color of the ocean, like we've seen in the past slide, and even sometimes produce a foul smell. This can also be harmful to a variety of Florida's marine animals, since the toxins that they produce can lead to a range of symptoms such as paralysis, seizures, and in worst cases, death. Well, I hate to say it, but I don't think the fish in this picture are all simply just taking a group nap. Next up, another powerful image that truly demonstrates how red tide blooms can have a devastating impact on different forms of marine life. These dead fish are floating in the water of local marinas in Florida, and I believe that it's pretty hardcore evidence of the toxic effects that algae blooms in Florida can have on marine animals. When the red tides occur, the toxins released by the algae can harm marine creatures by causing respiratory distress, which can lead to, obviously, this form of death. Now, I don't know about you, but after seeing this image, I think I'll be laying off the seafood for a while. Jokes aside, I personally found that this picture really captured the severity of the issue at hand here with red tides. As you've seen on the previous slide, red tides can have an extremely devastating impact on marine life, but it's not just marine life that's at risk here. In fact, human health and the local economy can also suffer significant consequences. First, since red tides can lead to large-scale fish death, commercial fishing and seafood businesses can face significant losses. Furthermore, the toxins produced by red tides can without a doubt contaminate seafood, causing many food safety concerns, and even live fish can carry the toxins, so catching them alive doesn't necessarily guarantee their safety for humans' consumption. And the toxins released can cause respiratory problems for humans who either consume contaminated seafood or inhale the toxins. On this slide, I have a visual representation of the food chain and how harmful algae blooms can impact all levels of the ecosystem. At the bottom of the food chain, we have plankton and crustaceans that typically consume on these algae blooms. These small organisms then become the prey for a variety of marine life, as you can see here, and as these animals can feed on contaminated prey, they accumulate harmful toxins in their bodies, and eventually these animals always tend to make their way back to us, and as a result, we may end up consuming the toxins that pose a real health threat to ourselves. And overall, I found it important to consider that there are many different paths that the toxin can take to reach us, and that the health and survival of these animals are directly impacted by red tides. A changing climate, a changing ocean. As human activities such as burning fossil fuels continue to produce high levels of greenhouse gases present in the atmosphere, I feel the ocean's temperatures tend to increase, and which can have significant impact on the growth of algae blooms. And as water temperature increases, the rate of photosynthesis also increases, which can trigger the formation of red tides. Additionally, long-term global warming from climate change has caused sea levels to rise by melting ice caps, resulting in warmer oceans as well as water expansion and flooding. And this flooding can actually lead to discharge of nutrient-rich water into coastal ecosystems, which can promote the growth of algae blooms. And also, rising sea levels can also affect ocean currents and water circulation patterns, which can influence the distribution of certain nutrients. And changes in ocean currents over time can also impact the movement of essential nutrients like nitrogen and phosphorus, which are really essential for the growth of algae blooms. How climate change and ocean currents will continue to shape Florida's coastline. It appears that red tides are here to stay and are likely to become even more prevalent over time. It has been said that the escalation of the Earth's water cycle due to climate change is expected to lead to changes in precipitation patterns, and these changes include more frequent rainfall events like thunderstorms and hurricanes, which can result in higher rates of runoff from agricultural and urban areas. And this runoff carries nutrients like nitrogen and phosphorus into nearby bodies of water, including the ocean, which can stimulate the growth of algae blooms. And I also feel it's important to note that the Gulf Stream is a strong ocean current that flows along the entire eastern coast of the United States, and it surprisingly plays a pretty significant role in the movement of water and nutrients. As temperatures increase, the Gulf Stream current may move faster due to less dense waters, which can enhance the transportation of nutrients around Florida. And this may actually result in the spread of algae blooms even beyond the coast of Florida at some point. Okay, so this is the map of Florida from August to October of 2018, and it shows the changing of concentrations of algae blooms in cells per liter. And as you can see, originally algae blooms were primarily concentrated on the western coast of Florida in August. However, by September, blooms had quickly begun spreading towards the eastern coast of Florida, and then by October, we can see that the algae blooms had spread even further, including to the southern coast of Florida. At this time, the concentrations of algae blooms on the east coast appeared to have almost doubled in area and reached up to 1 million plus cells per liter, which is crazy. So overall, I believe that this map did a pretty good job at stressing the rapid and alarming spread of red tides and how they can move over time over large bodies of water. Now, you might be wondering if these are two different beaches, but the truth is it's actually the same beach. I find that this picture shows quite a dramatic contrast between the impact of red tides on the same beach over time. To be more specific, the picture on the right was taken only about 3 months after the one on the left. Obviously, the beach on the left appears to be more vibrant and healthy, while the beach on the right appears to be more dull and lifeless. This contrast only continues to highlight the devastating impacts of red tides. So which beach are you going to choose? I don't know about you, but I'm going to be choosing the one on the left. I genuinely hope that these before and after shots demonstrate the importance of taking action to mitigate the effects of red tides, and that maybe we could work together in the future to have a future where beaches remain lively and thriving. Okay, so now I think it's finally time to ask ourselves the question, could we actually be the problem? When humans make waves. Well, one of the main ways we can contribute to red tide is through nutrient pollution. And nutrients like nitrogen and phosphorus, as mentioned before, tend to come from agricultural runoff, sewage treatments, and even lawn fertilizers, which can fuel the growth of algae blooms that cause red tides. Human activities that release greenhouse gases, such as burning fossil fuels, can also contribute to the warming of the Earth's atmosphere and oceans. In other words, as greenhouse gases trap more energy from the sun, the oceans absorb more heat, resulting in an increase in sea surface temperature. Additionally, I also want to mention that overfishing can also disrupt the food chain and the marine ecosystem by causing imbalances in the growth of red tide algae. Removing top predators can lead to an increase in the population of smaller predators like jellyfish, which mainly consume plankton, and plankton usually consume algae blooms. So this pretty much allows algae blooms to grow unchecked and to grow to be more harmful. In this video, I wanted to physically illustrate how excess nutrients and water pollution can make things even worse and when it comes to the formation of red tides. So we have rainstorms, which can happen over fertilized grass clippings, and they eventually get washed into storm drains. And we have fertilizer runoff from golf courses. And we have fertilized runoff, and we have agricultural fertilizer runoff, and we have manure runoff. And industrial emissions that obviously increase the amount of CO2 in the atmosphere. Turning the tides. Despite red tides being a relatively complex issue, there are still many actions we can take to reduce its impact. Firstly, we can address the root cause of climate change by reducing our greenhouse gas emissions. Boating can definitely contribute to the occurrence of red tides by releasing fuel, oil, and other pollutants into the water, which can alter its nutrient levels and chemical makeup. And additionally, we can reduce nutrient pollution by using less fertilizers or using fertilizers sparingly. Now, to better prepare for the red tide events, I find it really interesting that we can use satellite imagery to identify areas of algae blooms and computer models to simulate growth and movement of algae blooms based on factors such as temperature, nutrients, and ocean currents. These can pretty much help us predict the trajectory of red tides. And I find that the health of our oceans is intimately tied with our own well-being, and by taking action to mitigate red tides, we can protect the health of our land and sea communities. And we must work together to address this urgent challenge in order to ensure a sustainable future for ourselves and our fishy friends. Well, thank you for joining me today to learn about red tides and their impact on the oceans and marine life and society as a whole. I hope this presentation was both informative and eye-opening, and I just want to say that throughout my research, I really found it super fascinating about learning about the evolution of red tides over geological timescales and how they impact our oceans today. While this issue can seem pretty daunting, it's important to remember that there is indeed hope. And let's not forget the words of our wise little turtle friend here. Let's all strive to be turtly awesome and help make our oceans blue again. Thank you for listening.